When you look up at the night sky, do you ever wonder who's looking back? Because somewhere out there might be another version of you, of me, of us. Not science fiction, not fantasy, just math. Because in 1961, a quiet genius named Frank Drake sat down to answer the biggest question in the universe. How many alien civilizations are out there right now? Not just life, intelligent life, life that can send signals, build radios, maybe even destroy itself. And what he created was a simple-looking equation that cracked open the cosmos. N7 symbols, 7 mysteries, 7 steps to finding our cosmic family. But here's what they never tell you. This equation isn't just about aliens, it's about us. Because each variable is a mirror, showing us who we are, what we value, what we're destroying, and what we might become. So in this series, I'm going to guide you step by step through each part of the Drake equation, not like a lecture, like a journey, with stories, with science, with meaning. This isn't just astrophysics. This is existential therapy. And by the end, you won't just understand how many alien civilizations might exist. You'll understand why you matter in the equation. Let's start at the beginning. So the first letter in the Drake equation is our star. The average rate of star formation per year in our galaxy sounds cold, mathematical, but it's not. It's a heartbeat. Every time a star is born, the galaxy pulses. It breathes, it creates possibility. And right now, that rate is between 1.5 to 3 stars per year. That might not sound like much, but let's scale it. Over 13.6 billion years, that adds up to over 200 billion stars in the Milky Way alone. But here's where it gets personal. Our own sun was once just a cloud of dust, 4.6 billion years ago, a ripple in the cosmic womb. Then something, maybe a supernova shockwave, nudged it into collapse, and boom, our light turned on. And what's wild? It's still happening. Right now, somewhere in Orion, another sun is being born, maybe with its own Earth, maybe its own poet, or tyrant, or dreamer. So what can you take from this? Zoom out daily. Remember the scale. Your worst day is microscopic next to a star's birth. Start something. If a galaxy can create 3 stars a year, you can create one thing this week. A sketch, a song, a connection. Honor your origin. You are literally made of stardust. The iron in your blood was forged in stellar fire. Our star isn't just math. It's a rhythm, a song, a sign that the universe wants life. And if stars are still being born, maybe civilizations are too. Let's talk about FP, the fraction of stars that have planets. Now, this part of the equation used to be the scariest. Back in the 1980s, many scientists thought planets were rare, that maybe our solar system was a cosmic fluke. But then came Kepler, and everything changed. Kepler stared at one tiny patch of the sky and found thousands of planets, big ones, small ones, hot ones, icy ones, and suddenly the universe was pregnant with potential. We now believe that at least 70% of stars have planets, probably more. And not just one planet, systems, solar families, some wild and chaotic, others eerily similar to ours. Think about this. Every star you see at night might have its own orbiting world, and each world could hold its own story. Mountains, oceans, maybe even mirrors. But FP isn't just about numbers. It's about belonging. Because for centuries, humans looked at the stars and thought, this is all for us. But now, we know we're not the only game in town. We are not the center, and that realization, it doesn't diminish us, it humbles us. Let go of entitlement. The universe isn't here for us. We are a part of it, not rulers but residents. Support space research. Whether it's missions like TESS or James Webb, support the science that helps us look outward. Cultivate awe. Make it a habit. Go stargazing. Read cosmic poetry. Let the night sky recalibrate your soul. FP tells us we're not alone in the void, not because we found neighbors, but because the real estate for them is everywhere. Now we reach the number of planets per star with planets that could support life. Not just rocky planets, not just watery ones, but worlds with the right conditions. Temperature, chemistry, distance from their sun, the Goldilocks zone. Not too hot, not too cold, just right. Based on current estimates, that number is between 0.1 to 1. That means for every planetary system out there could be at least one Earth-like world. And in our galaxy, that adds up to billions. Billions of Earths we will never see. Imagine one, a blue planet orbiting a red dwarf. The sun is dimmer, but longer lived. The sky, tinted orange. Trees with black leaves to capture more light. Oceans that sparkle purple in the twilight. You'll never visit it, neither will I. But it exists, and that knowledge is a kind of ache, a beautiful ache. Because every time you feel small, every time you feel your life doesn't matter, remember, you are part of a universe that keeps writing new Earths. Learn astrobiology, not for a degree, for wonder. Learn how life might emerge. Protect our own Earth. Because until we reach those other worlds, this is all we have. Dream wildly, write stories, make art. Imagine what life might look like under another sun. Any isn't just a number, it's a lighthouse, reminding us that life is not a miracle of chance. It's a rhythm, a tendency, a possibility, and maybe, just maybe, a promise. Let's talk about FLAN, the fraction of habitable planets, where life actually begins. This is where science stops whispering and starts arguing. Because even if the conditions are perfect, even if the chemistry is in place, even if the environment is stable for billions of years, life still might not happen. We only have one example, us, one origin of life, one data point. But we know something miraculous happened here around 4 billion years ago. Simple molecules somehow woke up. They began to copy themselves, to compete, to evolve. It wasn't magic, it was chemistry, but it was also inevitable. That's the question. Is life a fluke, or is it what the universe wants to do when given the chance? The universe is under no obligation to make sense to you. Neil deGrasse Tyson, but maybe it's trying to show us something anyway. In 2023, researchers created protocells from simple amino acids in volcanic conditions. No enzymes, no magic, just pressure, heat, and carbon. Life's spark in a petri dish. And across the galaxy, that means FLAN might not be rare. It might be common. Right now, there may be microbes swimming beneath Europa's icy crust, or crawling in the methane lakes of Titan, or thriving under the crimson skies of Proxima b. You don't need aliens with lasers. You need life. Any life. Because if we find it twice, even once more, it means life isn't rare. It's the rule, not the exception. Track the latest astrobiology research. Set alerts. Read primary papers. Stay curious. Support space exploration. NASA, ESA, private space. Your attention drives their funding. Start a life journal. Not about your day, about life itself. Track weird species, watch documentaries. Make it your hobby to study how life bends and blooms. FL is the fire we still don't understand, but maybe we're made from it. Maybe consciousness is the universe witnessing itself come alive. So now we've made it from the stars, to the planets, to the very first breath of life. But here's the next question. What are the odds that life becomes intelligent? Because not all life climbs the ladder of thought. Earth is teeming with species, over 8.7 million by some estimates. But only one invented language. Only one launched satellites. Only one is asking these questions right now. So what does phi, the fraction of life that becomes intelligent, really look like? Here's the thing, evolution doesn't want intelligence, it wants survival. And for most of Earth's history, microbes ruled. For 3.5 billion years, no brains, just single cells dividing in the dark. Then came complexity, then animals, and only in the last few seconds of Earth's calendar, us. Think about it. It took 13.8 billion years of cosmic accidents, volcanoes, extinctions, ice ages, asteroid strikes, for atoms to ask why they exist. That's what you are, a moment where the universe became self-aware, but it's fragile. One different asteroid, one slight tilt of the planet, one extinction too far, and there's no Shakespeare, no calculus, no Voyager probe whispering to the stars. In a 2020 study, scientists proposed the rare Earth hypothesis, suggesting that the steps required to create intelligent life are so improbable that we may be utterly alone. But others disagree. They argue, once life begins, intelligence might be a natural advantage, because minds can adapt, communicate, innovate, and over time, survive. So, what's the truth? We don't know, but we can act like we do. Invest in your own intelligence, not grades, but thinking, curiosity, philosophy. Ask better questions. Teach someone else. One child, one idea, one moment of aha. It echoes across generations. Defend education and thought, because if intelligence is rare, it must be protected like a flame in the wind. Phi is the mirror we hold to ourselves, asking, what if we're the first? Or worse, what if we're the last? And now, we reach the final two pieces of the puzzle. FC, the fraction of civilizations that develop the technology to communicate across space. And L, the length of time they stay alive long enough to be heard. This is where the hope and heartbreak of the Drake equation collide. We can build telescopes, launch messages, scan the skies, but if no one's out there transmitting, or they've already vanished, the universe remains silent. Think about Earth. We've had radio for just over 100 years, a blink. What if every intelligent species only lasts a few hundred years before collapse, war, climate catastrophe, AI run amok, and so the galaxy stays quiet? Not because no one's out there, but because no one survived long enough to say hello. This is the great filter theory, and maybe we're staring at it right now. Because if FC times L is small, then we are alone. Or worse, surrounded by graveyards of civilizations who couldn't outlive their own brilliance. Prioritize sustainability over growth, not just as a planet, but as a species. Build resilient systems, from energy to education to AI governance. What we do now affects whether we make it to the stars. Share knowledge openly, because isolation breeds extinction. Collaboration might be our signal. If we're the first voice in the cosmos, let's not make it the last, because every second we survive, every child that learns, every signal we send into the void, it all says one thing: we are here, and we choose to endure. Before you go, if this video stirred something in you, that quiet sense of awe, of urgency, you're not alone. There's a whole journey waiting for you, one I've carefully built piece by piece, so you never have to search alone again. Watch the full Cosmic Civilization series now. It begins with a question that could change your life. Click here and binge the full playlist, or go back and rewatch the previous video. Asteroid Impact, how one strike could end humanity, because sometimes understanding the past helps us protect the future. Subscribe, comment, share, because what we're building here isn't just a channel. It's a cosmic classroom, a global signal, a survival manual for dreamers. And I'll be right here, guiding you, one light year at a time.